Good evening, everyone. My name is Mugara Albert, and today we shall be discussing fundamentals of artificial intelligence. Um, that away, I begin with Module 1, the AI history and its fundamentals. AI began with in the days of around 1495 with the ideas of Leonardo da Vinci, who came up with the mechanical need robot sketches, and later in 1950, Alan Turing with his test that questioned whether machines could think. The exact term artificial intelligence was officially coined at the Dartmouth Conference in 1956. And with time, AI progressed through different expert systems around 1960s to 1980s, followed by the rise of machine learning in 1990, and also deep learning in 2020 that shifted from the logic-based systems to learning models. And currently, the current trends and future, AI is powered by large data sets, and deep learning achieves human level performance in speech, vision, and translations. The future promises more automation and human-machine collaboration alongside concerns of fairness and ethics. Uh, Today, I'm going to be relating the fundamentals of artificial intelligence together with my project of saying language to text and audio AI system. So the evolution of AI mirrors data mining shift from rules to predictive learning, and the different types of intelligence are reflected in the artificial intelligence, which includes the logical mathematical reasoning and linguistic understanding. In my project for sign language recognition, applies machine learning to change the gestures into text and speech, which reflects the AI's trend toward learning-based accessibility tools. And Module 2 was about problem solving in AI. So the AI problems are in a certain process, and the certain process uh, have stages, if I can call them. They were described by the initial state, the possible actions, and a goal state. So when you combine all these together, they define the search process. So an example is like solving a maze. It involves a start state, the moves as actions, and then reaching the exit as the goal. So each state represents the current situation. Then the operators change states, and the goal is the desired solution. So in an 8 puzzle, moving tails are operators while arranging them correctly is the main goal. So in this, data mining is similar to exploring a state space where classification narrows the possibilities. So philosophy introduces the frame problem, deciding which details matter when solving such a problems. So in line with my project, uh, in my system, the captured gesture is the initial state, then the recognition algorithms are the operators. So, and then to generate a clear text or audio or speech is the main goal. So in module 3, we see problem solving by search. There are two types of search, uninformed and informed. So uninformed search, for it explores possibilities without guidance, such as the DFS, which may take longer paths, and BFS, which guarantees the shortest path. What do I mean by DFS? DFS means depth first search. Depth. So meaning something takes long. And then BFS for it stands for breadth first search. That one is takes guarantees a shortest path. So maze solving illustrates how DFS can go wrong while BFS systematically reaches the exit. So, for informed speech, this one uses heuristics that combine path cost and distance that estimates the guide exploration. So this makes search more efficient and practical in large problem spaces. So clustering in data mining simplifies searches by grouping the states. So while spatial intelligence for it helps visualize search trees. So philosophy relates through simulation, exploring multiple futures before making any decision. So in my project here, this system uses these heuristic search to prioritize likely gestures, making recognition faster and even more reliable than blind exploration. So when I go to the propositional logic, these ones represent facts as either a true or false. So now, for example, if this statement that says if it rains, then the ground is wet. So now this propositional logic enables structured reasoning, but cannot capture detailed relationships. So here we come in with the connectives, the propositional logic basics, like the and, or, not, and implies combine facts to form these rules. So an example here, I've provided an example that says if gesture A and gesture B are detected, then output what? X. So in data mining, association rules resemble logical statements, and philosophy connects the propositional logic to weak AI, while strong AI, for it requires the richer representation. So in my project, it will be using the if-then rules to link gestures to text or audio outputs. So this will make the recognition predictable and well structured. So now the first order logic, this is the knowledge of representation. Because first order logic, what do? They describe objects, their properties, and their relationships. So once those ones are clearly described, it makes it more expressive than the propositional logic. So for example, now, like a parent. So a parent, this shows a relationship between two people. Because a parent, there is a dad and there is a mom. There is John and Mary. So that shows a relationship between two objects. So now for components of first order logic, we have the syntax, we have the semantics, the quantifiers like for all and there exists. So these ones, for example, the all students study, there exists a student, all those are examples and first order logic. So frequent patterns in data mining can be expressed in first order logic format. And the Chinese room debate questions whether symbol manipulation equals true understanding. So in my system will use the first order logic, like the rules of all for all gesture, translate to ensure every gesture is translated consistently into text or audio, because that's the main goal. So when I go on to the next module, that is module 6, the inference in the first order logic. So inference derives new truth from rules, such as concluding. So Socrates is motto. This is from all Schumann's are motto. But Socrates is also Schumann. So in AI, deduction applies rules to facts to generate new conclusions. So in relation to my AI, AI system based on sign language to text or audio, there must be sound. And sound ensures conclusions that are valid if rules are valid, while completeness ensures all possible truth can be derived. So together they create reliable reasoning systems. And here, the data mining uses classifications output as facts for further inference. So philosophy connects through debates like the Turing test and the Chinese room about true understanding. That's like a reference. So, as I already said, the system uses this inference rule so that if multiple gestures imply a certain word, the system outputs the word consistently. So module 7 was about reasoning and uncertainty, where there was Bayesian reasoning. Bayesian reasoning updates probabilities when new evidence appears, making it useful under incomplete or in noisy conditions. For example, symptoms. When there are symptoms, symptoms may suggest a disease, but once you test, results will refine the probability. So probabilistic models, the Bayesian networks model uncertain relationships, such as between the diseases and the symptoms. So that connection is through the Bayesian networks. So they allow prediction to be updated with new inputs in real time. So naive Bayes in data mining classifies data based on probability. And here the philosophy reasoning about uncertain and belief. So when I try to connect this module into my system, you will see my system will face uncertainty from noisy gesture inputs. So probabilistic reasoning helps it choose the most likely interpretations, even if there is noise. So Bayesian networks, how is it structured? Bayesian network represent probabilistic relationships among variables using nodes and directed edges. So each node corresponds to a variable, and edges show conditional dependencies supported by the probability tables. So some applications of Bayesian networks, these ones can be used in medicine, like for disease diagnosis, and in machine learning for handling uncertainty. So Bayesian briefly makes reasoning and uncertainty more structured and efficient. And in this project of sign language, text, audio, and AI-based system, Bayesian networks can model uncertain gesture recognition by connecting hand positions, movement, and context to improve prediction accuracy. So the nature of planning in artificial intelligence, how does it go? This one involves choosing actions that achieve a goal while considering constraints and resources. So a classical planning will assume a known environment and a well-defined states, actions, and the goals. That is the whole process. So we have different types of planning. There is the partial order planning, this one which will allow flexibility by not fixing unnecessary action orders. So there is also hierarchical planning. This one will break complex tasks into simpler subtasks, making it easier to be understood. And in this system, planning is a critical role because it ensures that recognized gestures are processed in the right sequence so that sentences are formed meaningfully instead of random words. And lastly, it was module 10 where learning in AI, like briefly the introduction of machine learning. So for it, machine learning enables systems to improve performance through data and experience rather than explicit programming. So learning here can be supervised using labeled data or unsupervised finding hidden patterns, or reinforced best, that is learning from rewards. And the different applications of machine learning, we have image recognition, natural language processing, the robotics, and the other recommendation systems. So it is the foundation of modern AI breakthroughs like speech recognition and computer vision. And in this project of ours that we are handling, that I'm handling with my fellow groupmates, they use supervised learning where the labeled gesture datasets train the model to recognize and correctly translate the sign. Yeah, basically that this is it for the fundamentals of artificial intelligence. Thank you so much for listening.